Hey, what's up? Cheddar Bay Biscuits from Red Lobster. Today we are going to talk about graphing tangents. So you might say that we're going to talk about tan lines. Oh, I've been waiting all unit to tell you guys that. Isn't that hilarious? That's so funny. Anyway, yeah. So we're going to talk about graphing tangent. That's our sort of our last. You know what, we might do the other three, but it's our last main key fundamental non-inverse trig function. So it'll be pretty cool. It'll be fun. All right, so let's go ahead and look at our parent function, shall we? So for the parent function, we're gonna graph this stuff the good old-fashioned way by just plugging in numbers and seeing what happens, right? So for our x-axis, I wish I had labeled all the other ones before. Anyway, spoiler alert, they're not labeled yet. But what we're going to do is we're going to plug in some x values. We're going to go figure out what they are, and then we're going to get our y values, and we'll just put those on the graph, all right? So we're going to look at our traditional x values. We're going to look at all the 30-degree angles today. And then we'll probably get like halfway around, and then I'll do some fancy hand waving and be like, and then it's that number, huh? But it'll be fun, We'll have a good time. Might pick up ice cream on the way home, and you can tell your friends about it tomorrow at school. So we'll start with 30 degrees, which is of course pi over 6. For tangent, we need to remember that tangent is sine over cosine. And we need to remember that sine tells us the y value of the ordered pair on the unit circle, and cosine tells us the x. So to get tangent of pi over 6, we're going to take the y part of the ordered pair and divide it by the x part of the ordered pair because of that equation right there. Cool? So when we do 1/2 divided by pi over 3, I've already done this ahead of time, but I put it in a calculator. We're going to just get a decimal to make our lives easy. It's about 0.577. I believe as like an exact number, this is radical 3 over 3. But as the decimal, because, 5 out of 4 people struggle with fractions. All right, next one is pi over pi over 3. That one is just the reverse. This is radical 3 over 2 divided by 1/2. So dividing by 1/2 same as times 2. So this is just radical 3. And radical 3 is 1.73. Cool. Now let's look at 90, and then I'm going to kind of hand wave the rest of this stuff. 90, or pi over 2, would be 1 divided by 0. And 1 divided by 0, this is like the most grievous sin you can commit in math, right? Like, I would rather have you tell your grandmother you don't appreciate her cookies at Christmas time than try and divide by 0. So what happens here when we try and divide by 0 is you break the laws of math. That's illegal. I'm calling the cops, and I'm going to have them haul you off to math jail. So what we put for that is just undefined. What that means is you don't put a point there. If we think way back to whatever unit it was, the rational functions unit, when we tried to graph something like x plus 3 times x plus 2 over x minus 1, at x equals 1, because if you plug 1 in there, you get 0 on the bottom, what we got was a vertical asymptote, and our graph would do something like this, right? We're going to get the exact same thing. What undefined does to a graph is it puts a vertical line that is invisible, and you are not allowed to put a point there. It's like an invisible boundary where weird stuff happens. Okay? So moving right along, we're going to look at 120, 150, and 180, and then we'll call it we should probably do 0 too, huh? All right. So 2 pi over 3. That is radical 3 over 2 and 1/2, except now the 1/2 is negative. So it's the same number, except a positive divided by a negative is negative. So now we have negative 1.73. For a very similar reason, at 5 pi over 6, you're going to get negative 0.577. And then at 0 and at 1 pi, we have kind of the opposite problem of this, right? What's the opposite of infinity or infinite? Actually, I shouldn't even put that in your head. Some people say that undefined equals infinity. Not true, but we'll see what kind of happens there anyway. So if you think about it as infinity, what's the opposite of infinity? Well, 0 divided by 1. If you have no things and put it in one group, that group has no things in it, right? So pi and 0 are 0. All right, so let's go graph this stuff right here, and then I'll tell you the trick to it, and then we're off and we're graphing tangents. So at 0 on the x-axis, we're at 0 on the y-axis. So our first point is on the origin, which is tight. For pi over 6, we are at 0.577, so a little higher than a half, we'll say right there. At pi over 3, or at 60 degrees, we are at 1.73, so almost at 2. Oh, hold up. Let me tell you how I'm numbering these, huh? In case it wasn't clear, this is 0.5, this is 1, this is 1.5, and this is dose. Okay, now that we're all on the same page. So 0.577, this would be 3 tick marks, 1.5, and then almost halfway to 2. So we're going to say right about there. At pi over 2, we are undefined. So what we need to do is put our vertical asymptote, and let me not be lazy about this. Let me use a real dashed asymptote. I said the real asymptote. Okay, there we go. So we have our vertical asymptote at pi over 2. Then at 2 pi over 3, we're at negative 1.73. So down 1.5, almost 2, right there. Then we are at negative 0.57, right about there. And then we're back at 0. So on this side, what we can see is our graph is doing something like this. And then here on the other side of the asymptote, we're getting something kind of like that. And that's tangent. If we continue this on, once we pass pi, once we go past here, 7 pi over 6, we're using the same things as 30 or as 150. But they're both negative. So we're going to end up a negative divided by a negative is a positive again. What happens is you get this curve, and it just repeats here. So like our other trig functions, tangent also repeats. So we're going to be a little over 0.5, 1 3/4 thereabouts, vertical asymptote. Ooh, that's ugly. Something like that. So our tangent graph, as it gets really close to the asymptotes, when it approaches it from the left, right, I'm on the left side coming towards it, you can see your graph goes up and it just continues up, up, up forever. The reason for that is if we look at, let's say, like 89 degrees, right, your y value is super big. It's like 0.97, let's say. And then your x value right here is like 0.01 or something, right? So this number divided by this number is like 970. It gets super large. As you very slowly take this point and rotate it around here, the closer you get to 90, the closer you get to infinity. Of course, you can never get there, right? Infinity is not a real number. So what happens is you get this undefined where math just stops working. It breaks because you try and divide by 0, which is illegal. But on this side, you get to infinity. But on the other side, as soon as you pass over to here, we have a negative x value, and then it flips the whole thing. And then you're down here at negative infinity, and then you come up. So the end behavior, quote unquote, it doesn't end, it repeats, but as you get close to these asymptotes, you're either going to go up to positive infinity or be down at negative infinity. Okay, cool. There we go. So there's tangent. This repeats. One other point I'd like to point out to you that's not here, because it's not one of these nice numbers at an increment of 30 degrees, but 45 degrees, we have radical 2 over 2 and radical 2 over 2. So if we divide that, radical 2 over 2 divided by radical 2 over 2, anything divided by itself is 1. So 45 is halfway between 30 and 60. So here's 30, here's 60, here's halfway. That should be at about 1. Likewise, here, this is halfway between 2 pi over 3 and 5 pi over 6. That should be at negative 1, right? So when you get to the 0, if you go over a tick mark and a half, it should be at 1 or negative 1. There's no such thing as an amplitude for tangent, because remember, amplitude is the distance to the maximum. This thing goes up forever, so the maximum doesn't exist. There is no max. It goes up as far as you want. You can, if you want to go higher, you just get a tiny bit closer to that asymptote. So, all right, cool. So here's the parent function. It's going to keep doing its thing. It's going to be there, then about there, then there. And it'll do that. And this side does that. And it just repeats forever. Cool? All right. So, important things you are supposed to learn from all that. The period of tangent is not 2 pi. Here we have a full up, a full down. Notice that happens at pi. I don't have to go all the way to 2 pi to get it to repeat. Half of pi, 0.5 pi, to 1.5 pi or 1.5 pi. These are only pi apart, and you have the entire graph of a tangent. Okay. The only weird thing about tangent is that the period is upper half vertical asymptote lower half instead of being one continuous thing. It depends on how you look at it, but the important thing here is our period is no longer 2 pi. Tangent repeats every pi instead, so it repeats twice as often. The other thing we want to notice is that every half period, so if our period is pi, at pi over 2, we are undefined. We have vertical asymptotes. Tangent starts at whatever your midline is. It starts at 0. Of course, we could take the whole thing, shift it up or down, and that would be our midline. Midline still exists. So we're going to start on the midline, and it has no maximum or minimum. All right, cool. So that's what tangent looks like. Let's go graph a couple of tangents just to kind of sink our teeth into it. I picked some pretty manageable examples. These can get real weird. We can shift them and stretch them and flip them and do all kinds of weird stuff to make it really obnoxious to graph, but I'm going to try not to overwhelm you. So here we go. Oh, I lied. Not yet. Let's talk about transformations. So we have A. It does normal A stuff. It can stretch the graph. It does not tell us an amplitude anymore because amplitudes don't exist for tangent. And if it's negative, it can flip the graph over as well. Okay. B will still change period. But our formula for the period is no longer 2 pi divided by b because our period didn't start as 2 pi. Our period is just pi over b. So it's the normal period of the function divided by your value of b. H is still horizontal shift. And our horizontal shift is still screwed up by b. So your horizontal shift is still h over b, and k is still your vertical shift. Okay, your midline is also still, that's not how you spell the word line, try again. Your midline is still y equals k. Cool. All right, but now let's go graph some stuff for realsies this time. Okay, so we're going to graph y equals 2 tangent of x minus pi over 6 plus 1. So you're going to notice I didn't give you a b value because I'm not mean as heck. But it means you're going to have to sit and watch me. Actually, watch this. Watch this. Please tell me I... Of course I didn't. Okay. Never mind. You're going to have to sit and watch me number stuff. Okay. I apologize. This is super unprofessional. You can have your money back, actually. Just tell my manager, call my boss, tell him, hey, you know what? He made me sit and watch him number an axis. Can you believe the audacity of that man? I refuse to sit and watch him number an axis. I demand my money back. If you don't give me my money back, I'm calling the President of the United States. And then he'll sort you out. If you have trouble getting in contact with that dude, just continue to hold. What's the next one? 3 pi over 2? Yeah, you're right. 3 pi over 2. Thanks. I appreciate that. What's the next one? 5 pi over 3. The old 5 pi over 3 trick, huh? 5 pi over 3, 11 pi over 3, and then, no, over 6, excuse me, and then 2 pi. Cool. All right. And then, of course, you've got to sit and watch me label the backside, of course, right? Who wouldn't want to sit and watch me label the backside? All right, now we're ready to rock and roll. So let's talk about our transformations first. So our first transformation, you're going to notice that 2 right there. This is going to stretch by times 2. We're going to double everything. So whereas our tangent of 30 was 0.577 before, we're going to have to double that to 1 point, whatever double that is. Right, and you're probably sitting there screaming at me. 0.577 times dose, 1.154. Cool. And so on. So we're going to have to double some stuff. We're going to kind of guesstimate these anyway, so I wouldn't trip about it too much. This h value right here, remember h is our horizontal shift, and because it's minus, we're going to go in the positive direction, pi over 6. And then this is going to shift us up 1. It's our vertical shift. All right, so let's get going. Okay, so our vertical shift, that's going to move our midline to 1. So let's go ahead and put our midline on the graph first. What color do you guys like? Purple? Me too. All right, so there's our midline. Let's make a dash so that we know it's not a real line. Okay, so typically tangent starts at 0, except we are shifting the entire thing to the right pi over 6. So that means instead of starting at 0 here, we're going to start on our midline at pi over 6. And again, in case it's not super obvious, this is going to be 0.5, this is going to be 1, 1.5, 2, 2.5, and so on. Okay. Now, normally, our vertical asymptote is going to be at pi over 2, except we took our whole graph and shifted it pi over 6 to the right. So pi over 6 is 1 tick mark. So instead of putting our vertical asymptote right here at pi over 2, we're going to shift it 1 to the right. So vertical asymptote. And then we know that this happens every pi apart. So we're going to go over 3 more tick marks. 1, 2, 3. Vertical wait. I didn't count that correctly. It doesn't happen every... I lied to you. I apologize. I shouldn't do that. That's a very bad habit, you know. Don't lie, you guys. Happens every... No, it does happen every pi apart. Duh. Except 3 isn't pi, right? Pi is 1, 2, 3, 4, 5, 6 tick marks. So we need to go 6 tick marks from this one. 1, 2, 3, 4, 5, 6. There we go. I know how to count. Okay. Then we can go backwards. 1, 2, 3, 4, 5, 6. And we can put another vertical asymptote right here. All right. So we have our starting position. When we graph this parent function over here, we had 0.577, 1.73. Those are distances from our midline, right? This is up 0.577 from the midline. This is up 1.73 from the midline. So we're going to follow that pattern. We're going to keep moving that far from the midline. So we're going to go over 30 degrees, or over 1 tick mark, pi over 6, and we're going to go up 1.54 from the midline. So we're going to go 1.54, so about there. We're going to go over a tick mark. 1.73 times 2 is going to be 3.46. So we would have to go up 3 from the midline. So 1, 2, 3. It's going to be like way up there. It's pretty high up. That's probably not far enough. Likewise, if we go left from our starting position, we went down this far. So we're going to go left 1, down 1.154, about there. Then we're going to go left 1 more, and we're going to go down negative 3.46 from the midline. So we're going to go down 1, 2, 3, and almost a half. So we can draw our tangent function. Ooh, that's ugly. Let me try that one more time. Looks like that, and then looks like that. Then we know this thing just repeats. So we're going to go down 3.46 from our midline right after we cross this vertical asymptote. So down 1, 2, 3, and almost a half. Go over 1. We're down 1 and a little bit from the midline. So down 1 and a little bit from the midline. Midline. Up 1 and a little bit. And then, of course, way up there. And this is our tangent. So notice that this stretch makes it really hard to graph. It's kind of weird. These shouldn't be perfectly straight. They should be curved, kind of parabola-y. But again, this is me trying to hand graph stuff. It's not going to look pretty. I apologize. If you want pretty stuff, go to Desmos. So there's our first graph. All right, let's go do one more. So here, nice. No amplitude change, so it's not going to get stretched out. We have just 1. Let's go ahead and flip it over, though. You know what? I meant to put a minus here. You can tell. See, there it is right there. So this minus is going to reflect. Hang on. How do you spell reflect? Reflect the graph. This is going to shift our midline down 2. This 0.5 is going to change our period. So let's calculate that. Our period equals pi divided by our b value. So divided by 0.5, that's 2 pi. Okay, so we're going to take our graph that normally looks like this. And what it's going to do is it's going to make it look like this. Right? It's going to make it wider. Okay. All right. Okay. Now we have to calculate our horizontal shift because we do have a horizontal shift, but because we have this b value, it's going to screw it up. So our horizontal shift is going to be equal to our h value, which is pi over 6, divided by our b value, which is 0.5. I'm going to put it as 1/2 to make this a little easier. Remember, when you divide by a fraction, we're actually going to flip and multiply instead. So flip the bottom and multiply. So 2 over 1 is just 2. So this could be 2 pi over 6, and then 2 and 6 reduce to pi over 3. Because this is negative, that makes h positive, and we're going to go right pi over 3. So let's Watch this. I've got you guys this time. I'm not going to make you watch me label another axis. We'll just do it the hard way. Let's move all this stuff out of the way. Come on, get out of there. Yeah, get that point out of there. Get that point out of there. Select all that jazz. Copy, paste. Welcome to 2020, ladies and gentlemen. We're living in the future. Perfect. Beautiful. All right. So now that we have all the important key features of our graph, we're going to go ahead and start graphing. So let's go ahead and put our midline down. So our midline, let's see, what color do we want it to be? Green? Nah, not green. Forest green. It's going to be at -2. Let's go ahead and go by ones this time, maybe? Nah, we'll keep going by the... Nah, let's go by ones. So we're going to label these as... So this will be 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Forest green, like my mom used to make. And we're going to put our midline at our K value. All right. So now our vertical asymptote, let's see, I don't like those endpoints. Let's make this blue. Let's make it a little skinnier. Okay. So our full period is 2 pi. So our graph is going to repeat when it gets here. Halfway to the end of the period. Oh, no. Wait a second. Let's slow down. You're letting me get ahead of myself, you guys. Okay. So we're going to shift our graph horizontally to pi over 3. So we're going to go right, pi over 3. We're going to put our starting point there. Perfect. The full period is 2 pi. So I've gone right from 0. So I need to go right 2 from 2 pi. So let's see. Maybe right there and right there. Okay. So our graph is going to end right here at, let's see, this is 13 pi over 6. So this must be 7 pi over 3. That'll be our ending point. That's when it's going to repeat. Halfway between, or halfway through our period, that is going to give us a vertical asymptote. So if we go halfway, half of 2 pi is pi, and pi is 6 tick marks. So we're going to go right 6. 1, 2, 3, 4, 5, 6. Vertical asymptote. Okay. Let's get rid of that. Beautiful. All right. Likewise, we can go left 6 from here to get our other vertical asymptote. So it'd be 1, 2, 3, 4, 5. And then maybe one more. So vertical asymptote right near the edge. There we go. Okay. So now, because this is all stretched out, our pi over, or pi of 30 and our pi of 60 aren't really going to work here. So the important point that I like to have kind of memorized, just give me something to shoot for, is halfway between the 0, or the point on the midline, and your vertical asymptote. That's where your 1 is. Your tangent of 45 degrees equals 1. This is halfway between 0 and 90. So between 0, which is your midline, and 90, which is your asymptote. So halfway between this point and this is where 1 should be. Or in our case, because it's negative, it's going to flip and be -1. So this and this are 6 apart, right? 1, 2, 3, 4, 5, 6. So if we go over 3, that's halfway. So 1, 2, 3. This is where our 1 should be. But because our graph is flipped, we're going to go -1 from our midline. Likewise, if we go left 3, 1, 2, 3, we can go up 1. And then we can kind of guesstimate our tangent graph from there. It's going to look something like this. Whoops, that should go like that. And then over here, mid, 1, 2, 3, go up 1. Go right, 1, 2, 3, down 1. That looks about right. And there's our tangent graph. Okay. So you want to look for your midline. That way you can kind of figure out where all your zeros are going to be. You want to look for your horizontal shift, which is going to be given to you by your H value divided by your B value. And then you want to go ahead and start throwing some points on there. Okay. All right. Don't join the Discord today, you guys. That was really confusing yesterday. You guys all went somewhere. I couldn't find you. Today, if you need help, go to the WebEx. I'll be in there. Good luck on your homework. Hopefully this wasn't too mystifying. Just, wow, where did Barton get those random points? But if it was, go give me a piece of your mind. Let me know how you feel about it. See you guys next time.